Today I would like to introduce the nomenclature of alkenes. When naming alkenes, you first need to find the longest continuous carbon chain that contains the carbon-carbon double bond to determine the root of the alkene. The alkene is going to be numbered so that the double bond receives the lowest possible number. You'll follow the same rules for alkanes and alkyl halides to name the substituents. And if you have an alkene that could have stereoisomers, you need to use either the cis and trans or E and Z designation of those stereoisomers. Alkenes are always named as a suffix. We'll see later on that some of the functional groups can be named as either a prefix or a suffix, depending on whether they are the higher priority functional group by nomenclature rules, but alkenes are always named as a suffix. So let's take a look at a couple of examples. In the first alkene, I need to find the longest continuous carbon chain that contains the alkene, and that's here. We need to number the alkene so that it has the lowest possible number. In this case, it would be on carbon 1. Looking at the substituents, I have a 2-methyl, and I also have a 3-methyl. So I know that 2,3-dimethyl is going to be a portion of the name. So 2,3-dimethyl. Notice the comma between the numbers, the hyphen between the numbers and the letters. The root is pent because it's a 5-carbon alkene. The double bond could be located either at C1 or C2, and so we have to specify that it is located at C1. That is done by putting the number 1 after the root and before the suffix. So the preferred IUPAC nomenclature is 2,3-dimethyl pent 1-ene. It's been a recent change that the alkene number comes after the root. The old way to name these would be to say 2,3-dimethyl 1-pentene, where the number comes before the root. You'll see both of those methods of nomenclature used. For a cycloalkene, the alkene always appears on carbon 1, and you have to number across the double bond so that the other carbon of the alkene is carbon number 2. So here I have a methyl substituted cyclopentene. Now I've got to specify that the methyl group is on carbon number 1, so it's 1-methyl. But there's nowhere else that the alkene could be, so we don't have to specify the number of the alkene. It's at carbon 1. So this would be cyclopentene. 1-methyl cyclopentene. When multiple double bonds are present, the suffix changes from ene to diene to triene to tetraene, etc. So for instance, the first example, I have non-1-ene. Now that's the new way. You'll often see it named as 1-nonene, the old way. For the diene, the root actually becomes nana. So I'm going to have nana, then a hyphen, 1,3 diene. And hopefully you can see the numbers represent the fact that the alkenes start at carbon 1 and carbon 3. The old nomenclature would have been 1,3-nonadiene. There are no spaces in any of these names, commas and hyphens only. For the next molecule, I have alkenes starting at carbons 1, 3, and 5. So this would be nana 1,3,5-triene. Now the old way would have been 1,3,5-nanotriene. That's acceptable as well. And the last example, the alkenes are starting on carbons 1, 3, 5, and 7. So this would be nana 1,3,5,7-tetraene. There are some common names that you will see in IUPAC nomenclature. The vinyl, allyl, and methylene groups are particularly important for alkene nomenclature. To see examples of those, let's name the molecules shown here. The first one is named vinyl bromide. This is the first time we do see a space in the word. There is a space between vinyl and bromide. It would also be acceptable to name this as bromoethene. That's rarely ever done. The next example is allyl chloride. Again, there's a space between allyl and chloride. It would also be acceptable to name this as 3-chloropropene. Again, we don't need a number for the alkene. There's no other place that the double bond could be in a propene. It has to be on carbon 1. For the last molecule on the screen, I do need a number across the double bond. I know that it starts at carbon 1, but would it be 1 on this carbon, or would it be 1 on this carbon? To answer that, I have to see how to give the lowest possible number to the methylene. And I would number across the double bond and give the methylene a number 3 substituent this way. Otherwise, it would be the number 6 substituent. So this is 3-methylene cyclohexene. There is no space in that word. I do want to point out that methylene is also used to refer to the CH2 group in general. In other words, this compound is often referred to as methylene chloride. And there is a space in that name. It can also be referred to as dichloromethane. So summarizing what we've covered so far, you'll want to determine the root of the alkene by finding the longest continuous carbon chain that contains the carbon-carbon double bond. You'll number the alkene so the double bond receives the lowest possible number, and especially in the cycloalkenes, that means numbering across the double bond. You'll determine the name and number for any of the substituents that are present, and use the nomenclature rules that we've already seen for alphabetizing and using prefixes like di, tri, tetra, that type of thing. You'll want to use the E or Z designation for alkenes that have stereoisomers. Of course, the simple alkenes could be named as cis or trans. When there are multiple double bonds in an alkene, you'll use diene, triene, or tetraene as the suffix. And we've already mentioned that the alkenes are always named as a suffix. So this is a time for you to work a couple of examples. Pause the video and give these a try. So let's look at these one at a time. In the first compound, the longest continuous carbon chain that contains the alkenes is this one. So I'm going to have an ethyl substituent. This will be numbered so that the first alkene gets the lowest possible number, so I'm numbering from the left. And I'm going to have a 3-ethyl hexadiene. I have to specify where the alkenes are located, so it's hexa 1,4-diene. And this is a good time to go back and see if I need to specify the geometry of those alkenes as either E or Z. For alkene number 1, I don't have high or low priority on carbon 1. They're both H's, so I do not specify that as having a stereoisomer. But for the alkene on carbon 4, I do need to specify that it is a trans or E geometry. So cleaning up the structure a little bit, I noticed that on one side of the alkene, I have a carbon versus a hydrogen. Carbon is going to be a higher priority, and hydrogen is going to be a lower priority. And on the other side of the alkene, the alkyl group is a high priority group, and the hydrogen is a low priority group. So these are trans or E. So to finish up the name, in front, trans-3-ethyl hexa 1,4-diene, or instead I could use the E. No spaces in those words, even though it might look like it on the screen. For the second molecule, I have an octene, and it turns out that I can number from either end and put the alkene on carbon number 4. So remember, that comes back to the alphabetical order of the substituents. This one is a T-butyl that is alphabetized by the B, and this one is a methyl, alphabetized by the M, obviously. And so I number this left to right. So this is going to be a 4-T or tert-butyl, you can write it either way, 5-methyl oct-4-ene. Now going back, I do need to specify the geometry of the alkene. So let me clean that up just a little bit. Remember that we look at the substituents on either side of the alkene as we did in the first problem. A carbon bonded to 3 H's is going to be lower in priority than a carbon bonded to a carbon and 2 H's. The CC is higher priority than the CH. And on the other side, here I have a carbon bonded to 3 carbons, and that's going to be higher priority than a carbon bonded to one carbon and a hydrogen. The high priority groups are on the same side of the alkene, so this is going to be a Z alkene. So up front, I put a Z in parentheses, a hyphen, 4-tert-butyl, 5-methyl, oct-4-ene. Like, of course, it would be okay to say Z, 4-T-butyl, 5-methyl, 4-octene as well. Looking at the last example on the screen, I again need to number the double bonds so that they have the lowest possible number, and I need to number those double bonds in a way that gives the substituent the lowest possible number. So this is going to be numbered so that the ethyl group is on carbon 2. This will be 2-ethyl cyclohexane. Now we don't have to specify that as a cis or E-alkene because it's a 6-membered ring. You cannot make a 6-membered ring with trans alkenes present in the ring system. It's just too unstable. You need at least 8 carbons in the ring to be able to obtain a trans double bond. So if the alkene geometry is not specified in a ring, assume that it's cis. And I referred to both the Wade and McMurray textbooks when making this video.